I'm Nate Trost. Welcome back to The Game Show, where we're talking about what's new for game developers in Android 13, as well as the latest developments in Android graphics. Last year, the Game Dashboard was introduced on Pixel 6 and Pixel 6 Pro devices. With Android 13, Game Dashboard has become part of Play Services, expanding its availability to a wider audience. Game Dashboard provides an overlay for quick user access to actions like taking screenshots, streaming gameplay, or adjusting performance preferences. With the Game Dashboard, the user can choose to prioritize performance, prioritize battery life, or set a neutral default. You can use the Game Mode API to retrieve this user preference. Your game could do things like change your target frame rate, adjust graphics settings, or take other actions to respond. To use Game Mode, Android needs to know your application is a game. You do this by adding an app category attribute inside the application element of your Android manifest, and setting the app category value to game. You also need to add metadata entries declaring you support the battery and performance modes. You can create an XML file in the appropriate resource directory and reference it in the manifest. Inside the XML file, you declare your support by setting the support battery game mode and support performance game mode values to true. To retrieve the current game mode, you obtain an instance of the Game Manager system service, and then call its getGameMode function. You should do this on startup, and anytime your app regains focus to ensure that you have the user's current game mode setting. In Android 13, the Game State feature has been added to the Game Manager. Game State lets you provide Android with context about what your game is currently doing. You do this by creating a Game State object and passing it to the Game Manager using the setGameState function. Game State has a Boolean parameter that signals whether your game is in a loading state. The mode parameter is used to distinguish if your game is in a menu, an interruptible or uninterruptible gameplay, or displaying non-gameplay related content, such as an ad or a web page. You can include optional game-specific metadata with the game state, in the form of label and quality integer values. Setting a game state gives Android contextual clues that can help it apply interventions to boost performance at key moments, to do things like reduce startup loading times. Next, let's talk about adaptive performance. Android 13 brings internal improvements and increased device support for the adaptive performance APIs. These APIs can help you avoid runtime issues if a device begins to overheat. They also let you give Android contextual information about your most important CPU workloads. There's never been a better time to integrate these capabilities into your game. Two important APIs are the Power Manager and the Performance Hint Manager. The Power Manager's Thermal API lets your game retrieve the current thermal status of the device. Devices will perform performance throttling to manage high temperatures. This throttling can impact the runtime performance of your game. You can add a thermal status listener to receive notifications about changes to the thermal state of the device. The Power Manager can also give an estimate of how much thermal headroom is available before the device begins severe throttling. Monitoring the thermal state and estimated headroom can help you make runtime adjustments to your game to avoid thermal throttling. You might take actions like reducing your target frame rate or simplifying effects. The Power Manager is accessible as a Kotlin or Java API and API level 29 or higher. It can also be accessed directly by C++ code through the MDK and API level 30 or higher. The Performance Hint Manager, available in API level 31 and higher, lets your game create hinting sessions for game threads that are performance intensive. The threads in a hinting session are expected to have a periodic workload with a target duration for each frame. For example, a rendering subsystem with a target work duration of 6 milliseconds in the context of a 60 Hz game frame. After creating a hint session, you report the actual work duration following each completed workload. You can also update your session's target duration in response to changing conditions. To see a sample project that implements these adaptive performance APIs, visit the Android Game Samples repository on GitHub. Finally, we're going to talk about Vulkan. Android provides the industry-standard Vulkan API for high-performance graphics and compute functionality. Vulkan is a powerful, flexible API with lots of optional extensions, features, and formats. Vulkan profiles are a way to help manage that complexity. A Vulkan profile defines a required set of Vulkan extensions, hardware features, minimum capability limits, and data formats that a Vulkan device must support to meet that Vulkan profile. For developers targeting Vulkan on Android, we've created the Android Baseline Profile. You can think of the Android Baseline Profile as a minimum specification to require when initializing a Vulkan device. Compatible with Vulkan 1.0, the Android baseline profile includes a small list of required extensions and requirements for features like the ASTC LDR texture format. For more information on the Android baseline profile, check out its page on developer.android.com. Android 13 introduces platform support for version 1.3, the newest version of the Vulkan API. Device support for version 1.3 will grow over time. In a future version of Android, Vulkan-capable devices will be required to support 1.3. Vulkan 1.3 promotes many previously optional extensions into required features of the core API. Buffer device address is one example. With buffer device address, a shader can load an address from a buffer and treat it as a pointer in a storage buffer memory. Vulkan render path configuration and management can be a significant amount of work. Vulkan 1.3 requires imageless frame buffer, which can simplify render path setup. For rendering scenarios that don't involve multiple subpasses, the dynamic rendering feature can allow you to skip render passes entirely. Inline uniform block and uniform buffer standard layout bring finer-grained control and access to your uniform variables. In response to developer feedback, Vulkan 1.3 brings in new synchronization functionality and usability improvements, with host query reset, timeline semaphore, and synchronization 2 that can help achieve optimal throughput with complex workloads. So that's what's new for Android game development. The Game Dashboard now in play services with the Game Mode and Game State APIs. Improved adaptive performance with the Power Manager and Performance Hint Manager APIs. The Android baseline profile for Vulkan, and Vulkan 1.3 support in Android 13. For more information on everything I've covered, check out developer.android.com, our blog posts, and the Android Game Samples repository on GitHub. Until next time, happy game developing.